My name is Shannon Brown, and I work for Epsagon. And first, thank you so much for coming to the webinar. We are just over the moon that we have these three amazing panelists that you're about to hear their credentials, and then you're going to hear about me, and it's going to go, whoo. But we're really excited today. Today, we're going to talk about more than functions, a discussion about the future of serverless in observability, which is what we do here at Epsagon. We're going to try and make it the least marketing-esque webinar, so don't expect a lot of talk about Epsagon, but more about serverless in general in the future. So let me introduce the most important people, and when I do this, that's because I'm looking at them here, I apologize. So the participants we have today, first, Jan Kui. Jan, of course, anyone who knows serverless knows Jan. He's an AWS serverless hero. He's a well-known speaker and blogger on the serverless circuit. He's worked with AWS for 10 years and has extensive experience in AWS Lambda in production. He also provides content and has provided content for the serverless well-architected white paper that's been published by AWS and is the instructor of production-ready serverless. You can find him, and just so you guys know, I will share all of the finding these guys information at the end, but you can find him on Twitter at The Burning Monk or read his thoughts on serverless at theburningmonk.com. Say hi, Jan. There we go. All right. Next, we have Corey. He's a hoot. He's fun. Corey is a cloud economist who goes into companies and literally helps companies with their horrifying AWS bills. We're going to get to that a little bit later, Corey. He publishes Last Week in AWS, which is great publication. I suggest it. It's a weekly roundup of news throughout Amazon's ecosystem. He also is the host of a very entertaining podcast called Screaming in the Cloud, which features conversations with domain experts in the world of cloud computing in general, not just AWS Lambda. You can find him on Twitter at QuinnyPig. I will share it at the end. And you can find him online at screaminginthecloud.com. Say hi, Corey.
I am a treasure and a delight.
Absolutely. And Jeremy, I've had a lot of great conversations with Jeremy. I definitely go to him when I have questions for sure. Jeremy is the CTO at AlertMe with over 20 years experience in managing the development of complex web and mobile applications for domestic and international businesses. He has a weekly newsletter that I also get, Off by None, that focuses on the technical details of building applications and products in the cloud using serverless technology. So he really does focus on serverless. He's very active in the serverless community, and he writes a lot about serverless. So you can find him on Twitter at Jeremy_Daly and at JeremyDaly.com. Say hi, Jeremy.
Hello, thanks, Shannon.
Sure. Ron is the CTO and co-founder at Epsagon. He's also a passionate developer. I can tell you that for sure because he never sleeps, I don't think. He has vast experience in network, infrastructure, and cybersecurity software. He loves sharing open source tools to make everyone's life easier. You can see that with some of his blog posts about cost. He's been on the conference circuit speaking about his passion on serverless and the future of observability. And you can find him on Twitter at RonRIB. And that's it. Say hi, Ron.
Hi, everyone.
And finally, my CEO and also the other co-founder of Epsagon. He is also a software engineer with 12 years experience in coding, machine learning, cybersecurity, reverse engineering. He is a serverless advocate. He also can be seen speaking at quite a few, sorry guys, hello face, quite a few conferences and meetups, and you can find him on Twitter at Nitzan Shapira. Say hi, Nitzan. Okay, just a few things. Welcome to everyone else who's been listening. Don't worry if you missed it. I'm going to share the bios and how to get in touch with these guys and how to follow them online in chat, so please be looking for that. So just a quick format opener. Nitzan's going to talk about 5 minutes about observability and serverless. He's going to err towards not talking about Epsagon, although I think he'll brag on the team a little bit. And then I will introduce I've already introduced the panelists, but then I will go to questions with the panelists. I'll ask questions to specific panelists after they speak for a little bit of time, then the other panelists will be able to join in. The audience will be muted, but if you do have questions, please chat them in the chat. I just talked to the team that's on here, and they are willing to answer questions afterwards if we didn't get to them. So if you would like, I won't send you marketing email, or you can block me like everyone else. But if you would like to leave an email address, or you want to email me with a question that's specific for somebody, I'm more than happy to pass that information on. If we do have time afterward, we will open up for Q&A, and then we'll close it out. After we finish the webinar, we'll go ahead, we're gonna record the session. We'll share with you where the session is if you have to miss part of it, or if you wanted to share it with somebody else, because these guys are amazing. We would love that. So I think I'm going to hand it over to Nitsan. Nitsan, your turn.
Thanks, Shannon. Thank you all for joining, and mostly thank you, Corey, Jeremy, and Jan for being here. I mean, we really appreciate it, and I'm sure everyone will be interested to hear what you have to say. I'm just gonna do a quick overview and a background to the session. Not gonna be too long. So I'm just gonna share my screen before I start, and just a few words about the Epsagon and our team. So Epsagon was founded by me and Ran, so we are the two guys on the top left. We came from a background of cybersecurity and network operations and so on, and we started a company about a year ago. And what we did is basically researching the serverless domain, speaking with people, and finding out that monitoring and troubleshooting and what they call today observability is really a very big problem. And we've been funded since January. The team currently has 11 people, including experience from New Relic and AppDynamics. So we bring this knowledge of both deep cybersecurity and technology together with the APM. And we just launched last week, so we probably saw it on TechCrunch. And let's talk about what serverless is. So, you know, serverless is not really has a specific meaning. Everyone defines it differently. So what I think serverless is a mix of both managed compute and managed services that are tied together to create an application that is managed. So you don't need to manage the infrastructure, and you can focus on your business logic, and you can see the function as a service, such as AWS functions or Google functions, and of course, the managed services that are very, very diverse and are all connected together, so you can actually focus on your business logic without worrying about the infrastructure. And the benefits are, of course, the pay-per-use. So the server utilization is usually very low, and using serverless, you can kind of just pay for what you're using. And the main benefits, in my opinion, are actually the auto-scaling and the lower need for operations. So the infrastructure is managed by the cloud provider, and you can focus, again, on your application and iterate faster. And this is what can actually give you an advantage in today's market. And the adoption, you know, just looking at the recent survey, all the metrics show that it's growing about 2x compared to last year. And I mean, I don't have to tell you, you can look at the conferences, it's everywhere and it's growing very fast. However, it's still quite in the beginning. That's why these discussions can be very interesting. And the problem is looking again at the famous Jan drawing. I don't think anyone actually had a better one since. It's like once you did this, everyone was like, okay, this is done. No need to make another one ever. So, you know, the problem is basically people think about functions and how easy it is. You just deploy the function, it's working. But when you actually connect it to an application, this is usually quite complicated, and you can end up with a very distributed application, event-driven, a lot of components. And then when you think about how to monitor this thing, how to troubleshoot issues, how to understand performance, this can be very complicated. So this is where actually the problem comes from. And in addition, you have those unique problems to serverless. So you get timeout, you get out of memories. The cost can actually go up and you don't even know. So these are some things that are new in serverless. So combining both creates a big challenge that even in the last surveys is very dominant. So debugging, monitoring are the top two in this year's survey and also in the previous year. So it's definitely not getting better because the applications just get more complicated and that's why these problems are so big today. And just when we talk about APM or observability or whatever you call it, eventually as a company, people need the same things as they used to need in any kind of applications. They want to troubleshoot issues fast. In serverless, every small problem can become a big problem. So that's why troubleshooting becomes one of the first things people notice. And then you need to identify the serverless unique problems. So what about those timeouts, those out of memory? Maybe an API that you're using can cause your Lambda to timeout. These things did not exist in a server-based environment. And then the cost is another issue that people become a bit worried about. So how do I know what my bill is going to be? And how do I monitor this in order to enjoy the benefits of the pay-per-use? And just one last slide to say why we actually started the company and why we think the existing or the traditional tools did not fit. So many of them are just not distributed. So they just think about serverless as, okay, I had something for a server, let's try it for a function. And this works on a certain level, but once you gain some complexity, you need a distributed tracing solution. And this is true for microservices and containers as well. And the second thing is some of them are very hardly focused on agents, which cannot run in a function. So if the agent has all this logic inside of it, you cannot just take it into a function. It doesn't work. And another thing is the automation. So when you have hundreds or thousands of functions, you want to move fast, you want to iterate all the time. Being automatic is, in my opinion, very, very critical. And this is something that we have on our focus. And again, making sure you take care of the unique problems of serverless to kind of provide whatever monitoring you can expect. So you will be ready for any problem that you have. So this is just like the way we see the world of serverless and observability, and I'm happy to hear the panelists with probably much more interesting things to say. Thank you.
Awesome. Thank you, Nitzan. I really appreciate it. Okay, so I think it's time to go to the panelists. So the first question that I want to ask everybody is really just to give context. You know, we're here to talk about observability and the future of observability and serverless. And so what I think would be important is that everybody understand what each one of you thinks observability is. So if you don't mind spending maybe a minute or two, just briefly letting us all know what you think observability is. And let's go ahead and start with Jan.
All right, I guess for me, the difference between monitoring and observability is that with monitoring, you kind of looking out for those things that you know can go wrong in your system. But once you know something's gone wrong, how do you then actually figure out what the problem is? This is especially difficult when you've got a massively complicated distributed system where where the end results they can observe could be, say, user getting a slow response time, but then the problem could be hidden in so many different layers in your code chain. And having a good observability means that you can then ask questions that you didn't know to ask before and be able to debug any arbitrary problems that can come up in your system.
Nice. All right. It's going to be hard to beat. No, I'm kidding. Not a competition. Corey, your turn. What is observability to you?
Fundamentally, it's a buzzword to some extent, because if you call something monitoring in 2018, you're going to have a hard time selling it to people who think of it in the same way. I mean, the challenge you see with serverless is people love conferenceware, where you get on stage and start talking about how you're breaking a monolith into microservices, because fundamentally you want to turn every outage into a murder mystery. There's no good way to trace this back in the traditional sense. There needs to be a new set of tooling that winds up providing visibility into the ridiculous monstrosity of a labyrinth that you've built that no one can fit in their head at once. It opens up a whole new realm of, I want to say, failure modes that break in new and exciting ways and cause you to tear your hair out, and always play the game of, is it me? Is it the provider? Is it something else that I can't control? It's just a continuation of the old saw that everything is terrible, but now we have new ways of making things terrible. What observability brings is letting us know exactly how terrible they are at any given moment.
Love it. I'm okay. I like it. Ron, what do you think observability is to you?
So I'm really relating to Jan's answer, and I really think that being able to identify problems sufficiently and quickly as possible is the key thing that's going on observability. It's definitely an overused word, like everywhere. You can hear it on security, you can hear it on monitoring, and so on. But the thing that in serverless, things became much more distributed than before, and now identifying the issues, which can be a code break or even performance issues, are getting to be really hard to detect or to understand, like the real root cause analysis and not just what happened on a single individual function or resource. And it's to be able to tell the whole story, the full picture, or the bigger picture of what's going on in production.
Awesome. Great. Thank you. And Jeremy, what's observability for you?
Yeah, so I mean, I think observability is sort of one of those, it is a buzzword. I think Corey's right about that, but it's also an unintended consequence that developers and cloud architects actually brought on ourselves, because we started with these monolithic applications and something broke along the way. You put an item in your cart, you go to the checkout, you put in your credit card number, it reaches out to the payment processor, it fails, oh, there's a problem, everything stops. And then we said, well, yeah, but we want to make distributed systems because maybe, on Black Friday, we don't want our payment system overloaded. So we go and we build these distributed systems where we say, well, let's just say they tried to make a payment. We'll throw that in some pipeline somewhere. And then you have marketing who says, well, we want to know that somebody tried to buy something, because even if they don't buy it, we still want to know they tried to. And then you've got your analytics team. And so you start sending these events and messages all over the place, and it gets more and more complex. And there's no longer this clean linear failure path. And now it just kind of spreads out everywhere. And so if you look at how we monitored applications in the past, and you try to sort of attribute it to what we do now, or try to adapt it to what we do now, it gets much, much more complex. So to me, the idea of observability is not just being able to see the events sort of flowing through the system, but also the idea of being able to do that tracing, do that debugging, raise the issue of who's responsible, as I think, as Ron had said, trying to figure out what do we do? How do we diagnose that problem? And I think that's what observability or these tools that are being built around observability give us the option to do.
Nice. Well, I'm actually going to stay with you, Jeremy, to kind of extend on that, because you wrote in your serverless microservice patterns for AWS blog, it's from August of this year, you stated that you're a huge fan of building microservices with serverless systems. So I just wanted to ask you a couple of questions around that. First, tell us why, of course. And then second, a lot of people are moving towards microservices for distributed systems. What makes serverless a better choice for these types of architectures?
Yeah, so I think that, microservices is something that I started embracing a while ago. And again, you look at containers, you look at Docker, you look at those sort of things that could give you the ability to start breaking up your application into smaller parts. But the issue you run into is that microservices in themselves are these mini monoliths, right? So even though they may have a number of different functions and they're all around, you're splitting your organization into seams, you still have to scale that one unit, and that one unit is often complex. It's got databases behind it. It has a number of subroutines that have to run or whatever to make something happen. And the problem with looking at a traditional microservice is, in order to scale that up, whether you're going horizontal or you're going vertical, you have to scale the entire microservice. And what you run into problems with there is, and again, this is the worst example, but everybody uses it. The image processing example is to say that maybe you have a part of some service that has to process a massive amount of images. If you need to scale up your entire service and you don't just have a single image processing service, then you have to scale that entire thing. Which is overkill, and again, is sort of potentially a waste of money. It's over provisioning, and you don't need to do it. Where it's really interesting when you start looking at serverless functions is now you're looking at nanoservices. And some people talk about nanoservices being their own separate things, but I look at them as nanoservices being services within microservices. So you may have a small component of your microservice that needs to process millions of images or something like that. That with serverless, those functions, the individual functions, the few functions or the single function, the database, the managed services that are attached to it, those can all scale independently of the rest of the microservice. So now you could have a microservice that is going to scale as much as you need it to, but you'll have individual parts or those nanoservices that will also scale. And so you're basically perfectly provisioning your resources and your compute times and all that kind of stuff is now sort of perfectly scalable for what you need to do. Now, of course, there's limitations and there's all kinds of issues, that you're going to run into, with regards to scaling some of those things and back-end services and so forth, and what you might need to do with throttling. But overall, it's a much better approach, in my opinion, than to just trying to say, okay, we built this small little monolith that does our billing system. And now if we get a lot of activity on Black Friday, okay, well, now we have to scale it out to 100 containers or 1,000 containers or whatever it is in order to do that. With serverless, you might say, well, that service can just scale because the actual payment processing function, we can throttle, we can queue, we can do anything we need to do to make sure that we don't overwhelm the back-end systems. So it's just a much better approach, in my opinion. And then the other thing that I really like about this is the idea of tracking costs, right? And I didn't mention that when I said observability, but understanding how much you're being charged to do particular things, I think is a really important factor that is left out of the equation. So you can go and see, okay, this function ran, 20 million times and it cost us this much, and that's fine. But what we're doing actually at AlertMe is we are processing articles from publishers' websites. So we have a service that goes and downloads those articles, and we pay a certain amount of money for that processing piece. Then we run it through the IBM Watson's NLU, which is their natural language processing. And that gives us back a number of compute units. So we know exactly how much that cost us to run that through NLP. Then we throw that into a queue. We run it through another bunch of algorithms. If it doesn't pass certain thresholds, we have human curators that'll actually look and see whether or not the articles are high enough confidence rate, and then they'll go ahead and they'll approve those or disapprove them. And all of that information is tracked. So we know that it takes a particular curator 5.6 seconds or whatever it is to review this particular article. So if you look at it from a traditional approach, we knew how much it cost to download the article. We knew how much it cost for that user to, for the curator to review the article. We know how much it costs because we get the compute units from IBM Watson. But what we didn't know was how much of our server resources are we actually using? And now we can actually say, okay, to process this article, this function takes 22 seconds or whatever it is. And then to do this piece of it, it takes this amount of time. And while that may seem like getting really, really granular, for us, we base a lot of the things we do on volume. So we want to know if we download 50 articles a day from a particular publisher and X number of those have to be reviewed by curators because they're shorter articles and maybe they don't have all the data we need to make a good judgment, and that happens how many times per month, 30 times per month, whatever it is. We can actually look at the cost now and say, this is exactly how much it costs to provide this service right down to the compute level for this particular customer. In our circumstance, it makes a lot of sense because we're working with a lot of large publishers. We have a distributed team. So it's very helpful for us to have that type of information. Now, if you go back to the observability side of things, though, that comes with a cost, right? Because now you've got these individual, functions that are running. And if there's a breakdown somewhere in that, then somebody has to go back and look at the logs, or they have to go and try to figure out what exactly went wrong. We get this all the time when we have bad keywords or bad entities that get extracted. So being able to go ahead and trace that information is much more difficult in these distributed systems. I don't know if that answers the question.
No, it does. It's really helpful. And we see, and I'm going to actually ask Corey a question about this afterwards, but does anyone else on the panel want to raise their hand and jump in on this one? I think, Corey, are you itching? Are you, no? Ron?
Actually, I just want to add about what Jeremy said about the fine-grained scalability, that you can pinpoint the function or the method that needed to be scaled and not just scaling a big monolith which involves with lots of procedures and lots of stuff going on. So we can find, I can say from my experience at Epsagon, we've got some functions that are running millions of times per day, and we've got some functions that are running 10 times per day because they're just generating some reports. So the ability to scale only these, 3 functions that are using really high volume traffic and to understand and break down how much each one of them is cost is priceless. I don't want to scale like a random EC2 instance or any VM that's consuming lots of memory and lots of CPU and don't understand how much each of my resources is handling with. So it makes more sense to be able to get this fine grain of scalability to the resource that we need.
Yeah, and even just a little bit beyond that too is it's not just the idea of fine grained, it's also how quickly it happens. So if you think about trying to, I mean, I still have plenty of implementations that I deal with that are using OpsWorks to scale VMs, and if you need to bring a new one online, it has to run through all those chef scripts and all that stuff to bring that back up, and you're looking at, I don't know, 6-7 minutes before a new server comes online. And then the problem is that even if you just have to scale just back past that tipping point, now you bring on another M4 large instance or something like that is completely overkill for that tiny bit of added service that we need to deal with, or the traffic that we need to deal with. Whereas with serverless, I mean, cold starts aside, which are fairly minimal in most cases, you're looking at 3 or 4 seconds max before all of that extra traffic can start to be handled, which I think is a pretty amazing thing.
Yeah, for sure. Jan, did you want to jump in, or Corey, before I hit the next question? Okay.
No, I think the guys done a good job.
We'll leave the cost to Corey. So Corey, this is actually a really good segue, because I told you I'd get back to it, that on your LinkedIn profile, it says that you're a cloud economist who helps companies with their horrifying AWS bills. And so we've also been running into, customers that have had significant cost spikes, based on like a single bug. We call it the $50,000 bug. So, not specifically to AWS Lambda, but Corey, in general, what are the best practices to make sure your serverless application cost is according to budget and you don't get an unexpected bill?
Cloud economist is one of those great job titles because it's comprised of 2 words that no one can accurately define. It also, when someone walks up to you at a party and says, "What do you do?" and you say, "I'm a cloud economist," suddenly people realize they want to be anywhere but in the conversation they're about to have. So it really cuts down on the meaningless chit chatter. I'm going to talk about cloud economics, and even some of the panelists are already asleep. Right now, the way that we're seeing Lambda deployed in almost every company, even the serverless first environments, the cost of the Lambda functions, and to an extent the API gateways tied to it, basically equate to a rounding error. Even if they have no instances running at all, data transfer or storage costs wind up dwarfing this by orders of magnitude. If you see a company spending hundreds of dollars on Lambdas, they're spending tens of thousands on other things. It tends to be the sort of thing that today is not a major cost driver. The future of this is fascinating, where you can start attributing cost directly down to components of your applications, and that's great. But the economics of it tend to work out slightly differently. People tend to sit there and do the math out. Okay, with a Lambda function, if I'm running it throughout the entire month, what will it cost me, ignoring the instantiation fees? And they try and do an apples to apples comparison with EC2 instances, and they put a lot of work into it, and they come out with the wrong answer to a dumb question that nobody's asking. The problem that you see is that you also get a lot of stuff for free with Lambda. You get auto scaling on demand that is perfectly suited. You don't have to consult the bones to wind up calculating out your reserved instance usage for the next 3 years. You don't have to wind up mucking about with a whole bunch of load balancers and things like it. It abstracts away a lot of the toil, the tedium that everyone loves to complain about over their 8th beer when we're crying about cloud. The economic story, as far as what to do as you're going into it right now, is almost irrelevant in the context that it's not a major cost driver. As workloads shift, as people get more ingrained in this, that changes significantly. And the best thing you can do today to plan for that far off glorious future is tag appropriately. Make sure that you have a tagging strategy that works. Trying to go back later and figure out what drove what cost and why everything skyrocketed is challenging. Not just on a per function basis, but on a per service basis, per component. Being able to answer the question later when you suddenly scale massively and the CFO poops an abacus, kicks your door off the hinges and starts screaming. It's never about the money that was spent. It was about the fact that it was unexpected money. If you want to enrage an accountant, a CFO, an analyst, whatever, start a sentence with the word surprise, and suddenly everyone winds up having a very unpleasant day. They don't like changes to anything that impacts what they do because they're being asked to forecast 18 to 36 months out in almost every case. And doing that with something on demand that's spiky, being able to anticipate what that's going to be is and will continue to remain a challenge. But building out a corpus of data historically to show, okay, we know that when we have X users, it costs us exactly Y cents to service them. With their serverless themes, you don't have the same fudge factor in quite the same way. You know down to the very small fraction of a penny what each request costs to service, and the economic model becomes more accurate as a direct result. So it's going to cost us X dollars isn't an answer we're ever going to be able to give, but it will cost us X dollars per customer starts to be something that informs models a lot more effectively than that. Then it just becomes a debate over normalizing what a given customer behavior pattern looks like. I mean, the answer, of course, long-term becomes that it's complicated. There is no silver bullet answer to this. And I'm somewhat unconvinced that there's ever going to be a one-size-fits-most answer here, especially since you talk to 5 different companies doing interesting things with serverless, and you'll find at least 20 use cases that don't look like anything else. People are going in so many different directions with this that right now it's a wide open field. I think that trying to predict what patterns are going to emerge in a couple of years is a little bit of a fool's errand. But I do know that being able to have a platform that gives you a shared context to wind up viewing these things is increasingly necessary. And for better or worse, the native tooling offerings in this space are not super right now.
Okay. Anyone else want to touch on that?
Fight me.
All right.
Man,
Okay.
you've got a dog behind you. That's not a fair fight.
You're scared of the dog, Jan.
That's okay. She's not a real dog.
I was wondering how she's staying so still.
Yeah, right.
Excellent taxidermy.
No, but I would say that I think Corey's right. I mean, again, trying to get extremely granular or trying to figure out exactly what everything costs. I mean, anything that can help with the models. I think what you notice with serverless is that it is much more of a linear scale as opposed to this stair approach, which is the problem that you have with most like, you know, virtual instances or even containers to some degree. So I do think that as companies can look at those costs, and again, you know, you don't want to surprise your accountant, as Corey said, but if you can predict with some amount of accuracy that it's not, okay, well, if we add a new server, we can add another 1,000 users. And if we add another server, we can add another 1,000 users, where you can basically say, look, from a scalable standpoint, this is where it's going to grow. And even better than that is to look at it and say, I'm a small company. You know, look, I'm working off of a $1,000 a month budget that I gave myself to start this little tiny company or something like that. You could be very, very prescriptive about what you spent and could grow as the demand grew, as opposed to saying, okay, well, I got to get a bunch of servers to do image processing, and I got to get a bunch of servers to do ML, and I got to get all these other things. Now you have this ability to grow from these tiny microservices or tiny nanoservices and grow up. And I think that's an interesting approach, which is one of the reasons I think serverless is very, very good for startups.
Nice. Awesome. Well, thanks, you guys. I actually wanted to jump to my CTO for a minute. So Ron, we have a lot of experience with serverless at Epsagon because, of course, we use serverless. You know, we eat our own dog food. We also speak with people who, we have the luxury actually of speaking with people every day who are focused on serverless development. But we don't, in these conversations, often see traditional DevOps teams. We're seeing environments where developers are deploying directly to a production environment. So how do you think operations, DevOps, R&D teams, and organizations will evolve in order to develop and operate serverless apps?
Yeah, so what you're saying, that's actually true. Like, we're seeing developers are now like really focusing on the deployment and doing everything by themselves, and the ops are like left out of the party. And it's a bit weird situation because you don't want developer to handle the monitoring and all the CI/CD stuff. You want someone else to take care of it, and developers keep their velocity to develop their new business logic and the new features and so on. So I think what led to this issue was initially that developers are the one who brought serverless alive. They are the one who promoted it on conferences. They are the one who started using it all over. And they are the one who led the revolution. And as I said, it seems like the ops guys just felt we're still handling the Kubernetes and scaling issues and orchestration and so on. And developers just went to another branch and said, hey, we don't need it anymore. Just use a better infrastructure for that. And the developers themselves felt responsible for taking care of the deployment, the tooling, monitoring, troubleshooting, and so on. And if you take a look about the DevOps, it makes sense. It's something different. It's not the same thing that they're used to. Even if we're talking about it, DevOps is a new role. It's just, I don't know, born in the last couple of years around the world. And suddenly something new happened and there is new infrastructure that need to adapt to, and it's different, definitely. And I keep hearing the theme of serverless equals no ops, which is definitely not true. In serverless, there are different ops. I don't know how to say it in a nicer way, but there are definitely ops to handle, and it's different. And it's something that haven't arrived yet fully to the operations, because as we see, this whole ecosystem is still growing. We can see new tooling coming every day, like for deployment, definitely frameworks, some for monitoring, for security, for so many things that even for cost that we've talked about previously. And it's still being established. And I believe that once everything will be fully established and the ecosystem will be fully mature, you'll be able to hand over what the developers are doing now to the ops teams to be more function-wise, to run constantly on production. Just a few things about like what it means to do ops in serverless. So first of all, it's taking care for the CI/CD pipeline. I know it's pretty simple today to deploy a function, but once you're ending up with hundreds of functions, you really need to take care about how your CI/CD pipeline looks and make sure that you're doing the right versioning and so on, and how to orchestrate this whole stuff. And definitely there's the ops that relates to monitoring, to understand everything is alive and working correctly and and it meets the SLA that you're expecting. Also, we talked about costs, like who is going to monitor the cost? It's definitely not the job of the developer to understand how much the business flow of user registration is cost to his company. Someone else will need to take care for it. And ultimately, when you're talking about serverless, is mostly taking care for hundreds of resources, which are mainly functions, but also like the queues, the web servers, the databases, the storage, and so on. And someone will need to take care for it to make sure everything is playing, like in Opera, where you've got, I know, hundreds of people who are running something, and there is one conductor that makes sure that everything is running properly. So that's probably will be the DevOps role, but it will take time. I think that in startups we'll still see for the long term that developers will take care for it, and for enterprises we'll start to see the shift starting to go like over the time. Ops will take care for this stuff once they will be more mature.
Yeah, and Jeremy, you develop quite a bit in serverless, and you work, as a consultant with a lot of companies that are moving into serverless. What are you seeing? Do you have any responses to Ron's answer?
Yeah, I mean, ops is not going away. You probably read my newsletter this morning, but basically, I'm doing consulting for a company right now where I'm completing a risk assessment for the infrastructure. The infrastructure is entirely serverless, so I have to go through and we have to have disaster recovery plans, and we have to have backup plans, and all these different things that have to be in place in order to prove to a company that everything's going to be okay. And sometimes when you tell them, well, everything's serverless, so there are no servers, there's no way for somebody to hack into it other than hacking into our AWS account. There's ways that it can, security issues, but for the most part, a lot of those are mitigated. And so we don't have to worry about failover and backups and some of these other things the same ways we used to. So it's sort of a challenge to fill out these risk assessment things, because you want to just put NA in most of those columns. But no, so I mean, there's so much that operations still has to do, and it goes well beyond It goes well beyond just configuring and doing a couple of things like that. Yeah, you're not setting up the orchestration anymore, but you're still doing the CI/CD, as Ren said. You're still planning on that disaster recovery. Somebody still has to be responsible for monitoring the system. Developers, yes, they're closer to the infrastructure now, but at the same time, you're probably not alerting them at 2 a.m. if something goes wrong, right? So you sort of have a first line of defense, somebody that can trace those issues and then identify which of the 100 microservices, the issue happened in, and then potentially, then wake up the developer and because again, everything's moved down to application code where we don't worry about failures anymore so much at the infrastructure level. We worry about failures because some null value couldn't be mapped over, and that's causing an issue that's slowing down the processing of records or something like that. So that's where more is moving to. So I do think that ops people are going to have to take a step back and say, how can I help in the development of the application? How can I get closer to understanding how the code is working and what services it needs to interact with? But I think if anything, there'll be more of a sort of a conductor or a helper in that regard, but it's certainly not going away.
Yeah. And Jan, I saw your head. Do you want to chime in here?
Yeah, so I think it's true that a lot of companies are where the adoption for serverless is being driven by the application developers as opposed to the ops team. But I have spoken to quite a few companies, and in fact, my current company, as well as my previous company, a lot of the adoption has been driven by the ops team, because they also found that they also got this amazing tool that can allow them to do to automate a lot of the things that they have to do manually by hand or using very complicated scripts or mechanisms. Whereas now they have all these hooks into AWS environments with AWS Config, CloudTrail, and a bunch of other things whereby they can react to things happening in the AWS environment and to take better control using Lambda to automate a lot of the things that they have to do on a daily basis as well. So I also seen cases whereby the adoption has been driven from the other side, from the ops team, as opposed to the development team.
Yeah, yeah. And Corey, did you want to jump in on this one, or?
Not touching that one with a 10-foot pole. I have loud, angry opinions because I'm an old, grumpy ops person who has not quite adjusted to the new state of the world.
No,
Corey.
I just had these nightmares of like PHP scripts and and Perl back in the day to manage infrastructure, and I was having palpitations. So I'm gonna calm down.
Yeah, the nightmare ends. You wake up and then you have to do it.
Yeah.
Well, it was much easier managing a single Linux server running CGI, a CGI bin on the T1 line that was plugged into your office. That's when days were simpler.
Yeah, spoken like someone who was good at things. I don't know what that's like.
Me neither. I was terrible. All right. Okay. Well, Jan, the last question I wanted to kind of segue and follow up with you, because you speak a lot about the future of serverless, and I don't know if anyone that's watching, some of the attendees have, but certainly our team has watched your future of serverless talk quite a few times, and so I just thought for the people that are kind of seeing you for the first time, or maybe if you don't mind, talking a little bit about how cloud vendors evolve the terms of their serverless offering and what they're going to do regarding monitoring and tracing. So a lot of our audience, of course, is interested in the monitoring and tracing piece. So I was hoping you could touch on that. Oop, Jan, I can't hear you. I think you're on mute.
Oops, sorry.
That's okay.
I think up until now, I've seen a lot of companies that they adopt serverless, and it turns out to be the first time they actually had the first contact with AWS. I find that oftentimes these companies find themselves a bit lost in the whole complexity of AWS, and there's a lot of the current tools that we have. They do a good job in catering for this particular market and to make things accessible and simplify things for you. But then again, many of these vendors, they don't provide enough value add to what I get from AWS already. Maybe sometimes you get additional data points that I don't get from, say, CloudWatch, for example. But for someone who is already familiar with AWS, and they don't really help me out enough in terms of addressing the gaps that in what I have from AWS already. And I think as more and more these customers, they level up the usage of AWS, of serverless, and build more and more complicated systems, the vendors also need to up their game and cater for more advanced use cases. I think that's why I really like what you guys have been doing at the Epsagon, because I think from even early on when I was speaking to Nissan and Ran, when the guys were starting out, you were really focused on tackling the problem of chasing workflows as opposed to individual functions. And I think as someone who's been building, I guess, non-trivial serverless applications, that is the kind of problem that I run into all the time, as opposed to what's going on in one particular function. And from here, working in a much larger company now, I think as an enterprise, I also have many different use cases for the same tracing information from different angles. And as a developer, I'm interested in being able to debug my distributed workflow. And as the security team, I'm interested in being able to detect suspicious traffic flowing through in my infrastructure, and maybe proactively identify weaknesses such as over-permissioned functions based on what the function actually needs to talk to. And as the infrastructure team, I'm interested in understanding what my infrastructure is costing me and where to focus my optimization efforts so that I target bits of my infrastructure that's costing unproportionately high than other parts of our infrastructure. As the product team, I'm interested in understanding the cost of each user transaction to understand what features are profitable to me as a company, and really just how much I should charge for those features. I think of those things, you got this common intersection with observability and having that visibility into what's going on in my application. I think that's why observability is such an important piece of the puzzle. And as I guess with some of the existing providers I've worked with in the past, I think Stackdriver was a very good example, whereby on top of giving you that visibility, they also had a lot of tooling to diagnose potential problems before they happen and alert you proactively. And that's something I'd really love to see more and more vendors would do, so that something simple as, you just done a release and all of a sudden your performance profile for this function has changed. Maybe something has changed that you didn't intend to, so perhaps you should look into that. Or maybe something like, the cost for this particular function has gone up since you did a release yesterday. Maybe again, you made a mistake here. Things like that. I'd like to see the vendors do a lot more for me going forward. Even though with the right information I can do it myself, but it's just so much easier if someone else does the job for me.
I got you. Does anyone want to chime in on this one?
Yeah, actually, I can jump in. I can really relate to I think it was one of your last posts, Jan, with the percentiles and that we're doing it all wrong. And you mentioned it again right now, that observability, or in general, the need to understand what's going on in production, can be very different from each role to another in the company. For the product, it will be more breakdown of understanding what are his main business transactions and how long they take and how many times they occur, and even cost, like how much it costs. While for the ops, it's mostly monitoring, and for developers, it's troubleshooting, and for some, they want like amount of errors. Some will want only the ratio to understand whether they meet the needed SLA. So I can really relate to that, and it's correct. It's starting to get into my mind that you can't have a product that one fits all, because you can't have a single dashboard that will fit all the roles for all the serverless needs, and it's more like you need to have an appropriate view for each one of them, for each role.
Yeah. Jeremy, I see your head going up and down.
I'm just agreeing. I mean, I think that one of the things that serverless gives us the ability to do, especially from an event-driven standpoint, and I'm not sure if anyone's familiar with Rob Gruhl at Nordstrom and his idea of the distributed ledger, but it's this fascinating idea to basically say, any event that happens in the system, just capture it, and then decide later on if it needs to go somewhere, or someone can decide later on if it needs to go somewhere. And where it's interesting just in terms of, did an event happen, or did something happen as a result of an event? Those are the kind of things where if you have this ability to replay those events and you can see that sort of larger picture, it's just an interesting approach to that, in that we could replay those events and we could fix errors that happened, and we can go back and we could say, maybe we want to simulate those events to see why this particular function is taking longer to execute now or whatever. So there's a lot of benefits to serverless, and I know I didn't explain that anywhere near as well as Rob does, but there's so many of these benefits that you don't have with a lot of these traditional systems. But that does come down to like Jan said, if you can't if you can't find the right way to figure out where those issues are going wrong, just because maybe a function now takes 1 second extra to complete every time. That's a bad example, but let's say that's the case. At what point do you notice it? At what point does it become a problem? Is it a cost thing? Is it a latency thing? I mean, where is it? So the more tools we have and the different ways and the different facets we can slice and how we can look at that data, just becomes very powerful for developers and people working in these distributed systems to start pinpointing those problems and optimizing, for a solution.
Yeah. One interesting thing around that as well is we've been doing this for a very long time for BI. We collect as much information as we can about user actions and whatnot, and then we try so that we can ask arbitrary questions by running all kind of ad hoc queries. We should really start doing that for our own system so that we can have all, like you said, capture every event that's happening in the system, so that we can also then go back and ask questions to understand how our system is actually behaving.
Yeah. And Corey, I see you.
Oh, I'm still hiding here. It's.
I know. I'm trying to call you out, Corey. Come on, we need the entertainment.
No, I hear you. It's the problem that I tend to see broadly is that people are, in some cases, diving into this without really having a conception of what that means. Whether that means in terms of economics, which, okay, fine, that's where I live. That's not the interesting part of the story. There's also the point of where it comes from not knowing what that's going to mean for their architecture, not knowing what it's going to mean from a staffing perspective. It's, we have problems, 50 developers all clobbering each other. So now we're going to go ahead and build out a microservices environment and still wind up with a world of people who don't know how to communicate, because this is a political problem more than it is a technical one. These are still very early days. There's exciting times. And especially recently, to make this a little more timely, we saw that Lambda now has extended its runtime to 15 minutes, which is great and awesome, don't get me wrong. But that enables 3 really interesting and helpful use cases and millions of terrible ones. So by and large, if you're extending your runtime of a Lambda function past 5 minutes, you're almost certainly doing it wrong. There are exceptions to this, but as a general rule, don't go down that path unless you enjoy pain. At that point, it's, if we can get it to 45 minutes, we can shove our whole monolith into a Lambda function. Don't do that. I don't want to see a COBOL runtime. There is no AWS 400. So let's act appropriately here. Be responsible with the tools with which we're given to work. And that's something that's a challenge. Because again, going back to an earlier sentiment, you don't have people who have grown up doing operations and then pivoting over to this very often. The lessons you learn from working in operations come in the form of scars, where we did this thing and everything caught fire. So we know next time not to do it that way. We set fires in new ways, exciting ways. But those hard-won lessons are more or less being dropped by the wayside. So painful lessons around things like caching, for example, tend to wind up manifesting in new and exciting ways with Lambda. There are fun account limits you forget are there, so you smack into them and your site breaks. There's a whole list of learning opportunities here. So even approaching this from perspective, we can fire all of our hideously expensive ops people. You still need someone who understands the principles of how economics and how environments work how operational environments work in this context. And that's something that I think is somehow falling by the wayside messaging wise. There we go. Rant completed.
Nice. So I think that's all the questions, unless anybody else wants to jump in on this one again. We got about 7 minutes left, and I promised people that I would let them ask questions.
Also known as, do you know what your problem is?
Nice, Corey. Is there anyone online? I love you. Is there anyone that's watching, any attendees that would like to ask any specific questions?
Fight me.
Oh.
Maybe while we're waiting, I'll jump in on the 15-minute Lambda thing. So I actually think that the idea of letting a serverless function run as long as it needs to is actually a really good idea, because where we're going, and I think you see this with Fargate and a couple of these other things, and of course, if anyone's familiar with Serverless Framework V2 that's coming out, you can actually now launch either a function as a Lambda function or as a container. And the blurred line between the two, and I can see Corey shaking his head there, but the blurred line between the two is that essentially if you've got functions that need to run for a longer period of time because they're doing some sort of more complex level of processing. Doesn't have to be a monolith. I think there are examples here where that function will need to run for a longer period of time. Maybe a container is a better place for that, but the idea of being able to spin that up as quickly as a Lambda function can, I think, is a powerful concept.
Oh, if you could shove an entire container into it and run indefinitely, great. But in its current incarnation, if you have indefinite running Lambda functions, you ever leave the oven on and freak out and go back home to make sure it's off? Picture that with 10,000 Lambda functions left running concurrently. Sure. Yeah, there's no current great cost economics story around Lambda. Give it an indefinite run period. Oh, doggy, does that change? And it's like, wow, our phone number, it's not our phone number, that's our bill for the day. Oops. Yeah, we're adding commas at an unsustainable rate, and that winds up being a problem for people. So yes, there is a neat story around being able to do that. But I think it also is a regression in the form of how you wind up thinking about this. Something like being able to hand off to Fargate and blurring the line between those two, I'm completely on board with. To some extent, I think the more innovative aspect of this is the event model, as opposed to going down the path of just, ooh, I just throw code over the wall. That, in some ways, is more compelling of a story. But I'm not sold on let these things run forever, because again, there are 3 to 5 use cases that are super handy for that, and the rest are terrible. I'm going to run WordPress in a Lambda function, not Lambda functions, plural, a single Lambda function.
Well, yeah, and I mean, I think if you're looking at, you still have the event model though. I mean, that's the biggest thing is that it's got to be triggered by an event. So you're not sitting, it's not there just responding to ongoing events, the same thing, and now you're getting into state maintenance and all that kind of stuff. So I do think there's a big difference between that. I'm just thinking that if you have things that need to process, and I use the example in my post about maybe a video transcoding or something like that, where if that is a 25, 30-minute process, if you can do that by triggering that, compiled code that does that for you, and you can trigger 50 of those at a time if you need to, or 1,000 of those at a time if you need to, as opposed to scaling up more servers or scaling out containers or doing something like that. I think that's a really good use case. And I don't like putting limits on things just because somebody may misuse them or abuse them. I think that you need to give people certain freedoms, and where a lot of criticism of serverless comes from is to say, well, why only 5 minutes? Why do I only get 3 gigs of memory? Why can I only do this? Why can I only do that? And I think that hurts the adoption to some degree. I think I'd like people to say, oh yeah, I'm going to put WordPress in Lambda, and then let them realize that's a terrible idea. But for the people who need that extra compute or need those extra capabilities, don't tie or hamstring them, because I think there are plausible use cases that would make sense for.
There are. And to some extent, I think that the narrative for building that is something you want to gate to some extent. We saw this with S3 for a while, where you had a checkbox away from any authenticated user, which meant globally, not in your account. And we're still dealing with the fallout from that years later. It's one of those things where, yes, there are valid use cases, but by the same token, you're burying a landmine for people to step on. And that's not going to be a great feeling from a customer perspective. I think being able to reach out to get it unlocked for your account and then you sign a waiver might wind up being something that works a little bit better, but you're still going to see people who don't fully grasp this, and they learn how to fill out the form so it gets approved, and it winds up becoming this, it becomes a nightmare. And I think that a few stories like that resonate a hell of a lot louder than the interesting capability stories. One bad experience outweighs 10 good ones if you take a look at how people wind up viewing these things. From a pure engineering capability story, I agree wholeheartedly with what you're saying. It's wonderful. I'm just thinking of the human element as we take a look at the varying levels of technical sophistication of many AWS customers.
Which is why we need ops people, because developers need to be saved from themselves. Sometimes, not all of them.
I'm gonna unfortunately interrupt on that, but we wholeheartedly agree. I wholeheartedly agree. We need ops people. I think that's a good thing that came out of the panel. Look, nobody asked questions, but I do want to give you each the opportunity to say something. There may be somebody here that's just getting started with serverless. If you want to, give 1 or 2 quick examples of what's, a good application for serverless, or like a quick, sentence or 2 of advice. If you could, I'm going to go around the panel and I'll hit Nitsan as well. And then I think we're going to sign off. So Jeremy, you're up. Do you have anything to say to the serverless noobs out there?
Yeah, I mean, look, I mean, I love serverless. It's a complete change in sort of, it's a paradigm shift. It's a sort of a mind bend sometimes to think about events and how those, cascade and how that works. So it's a lot different than working with a monolith or even to some degree, individual microservices. So how functions communicate with one another is a lot different than how subroutines can easily be accessed and shared within a monolithic application. So my advice would be, really think about the smallest unit of compute that you can do. What is it? What has to happen to this event? And really get to think about events. So an event comes in, a file's uploaded, a user makes a request to an API gateway, something like that. What is the smallest amount of compute you have to do to that event to then create something useful as a result of it? And if you can think in those terms, then you can start to experiment. I am not in the camp that says never have one function respond to several API routes, for example. I think there are use cases where that makes sense, but think about scaling and always build all of your Lambda functions n+1 to always think that these things could scale up. Never build it in a way that would constrain it to only be able to run, with low concurrency. Awesome.
Thank you. Ron, you're next.
I would say from my end it's great to start with pick a random tutorial and start using Lambda. But if you're intending to go fully serverless, so read some tutorials, thorough tutorials. I know Jeremy and Jan got some nice one of them. Go through it, understand what it takes to really have a serverless application in production and not just a random function before you dive in. There are lots of caveats that you need to understand before you get into, like monorepo and how to monitor and how you detect cost issues and how you know about performance and so many stuff that you need to be aware of before jumping in, because it's not a shallow water, it's very deep and you want to know what you're getting into.
Nice. Yeah. Corey?
I would say that when you're starting out, take a look at things like the serverless application repo, look at GitHub for similar patterns to what you're trying to do. And if you can't find any similar patterns to what you're trying to do, jump onto a public forum, hire a consultant, not me, not my field, and have someone take a look at what it is you're doing. And if the response is a bunch of people looking at you like this, then maybe stop and think, is this an appropriate use case for it? Because most patterns that we've seen have evolved to the point of relative stability. If you're following one of those, you're probably on the right path. If you're building something new in far field, it's possible you've discovered something new and awesome. It's also possible you're about to make a grievous error, and you can save a lot of pain by talking to people who will shriek and then help you find a better way for that to go. One of the things I love about the entire serverless community right now is how open and willing to pitch in people are, even if the value of their entire contribution is no.
Nice. Thank you. Nitsan.
Honestly, I think you just said all the important things. It's I think it's just today, if you do something new, you probably should do it in the cloud. And if you do it in the cloud, you should probably think if it should be serverless. And usually the answer is yes. So I think serverless first is the way to go today.
Spoken like a true serverless fan. And
one other comment to weigh in on that as well is it does save you a lot of time going serverless with the second application. Expect the first one to be a little bit of a learning curve or learning cliff, as the case may be. I wound up figuring that out when I was 2 weeks into writing effectively a very simple application and sobbing. Just expect there to be a little bit of learning to think in new ways.
Well, yeah, I've rewritten serverless applications. I have one application I think I've rewritten maybe 6 times at this point. And it's quick because they're quick functions, but just looking at it from a different approach and choosing different things, yeah, it is definitely a learn by doing situation in many cases.
Right, and with
yeah,
that,
I must jump in as well. At Epsagon as well, we changed the architecture at least 3 times, like completely removing 100 functions and deploying new 100 functions, because as time goes by, you understand how how it's best to construct such architecture, how they should communicate with each other, how, like, it's stuff that you're getting from experience. You won't get them, like, hopefully someone will be able to put it on a tutorial, but it's more of experience thing to get.
Okay, and Jan, I'm gonna end with you, our local serverless hero. So what's your advice for the noob that's starting out?
I guess everyone has already said everything already. I guess just following along with what Corey said, don't expect a silver bullet. Serverless is not a silver bullet. It's got its own problems. Solves many other problems, but it comes with its own caveats. And yeah, when you're starting out, just try to read as much as possible. It's many of the people here on this panel, including Van and Nissan and all of you guys at Epsagon. They do a very good job in writing good content for the community and other people as well. I think Tom McLeod and the Pure guys as well, they all do very good content. So definitely go and spend the time to learn your craft and don't just jump in and expect magic to happen.
Yeah, thank you. And I think with that, we are going to end, but before that, first, thank you so much to the panelists. I learned so much today. We're humbled by having you again today. We really appreciate it. I do suggest for everybody who's an attendee, each one of these gentlemen have a ton of content. I get their emails, even if you're just starting out or if you're trying to go from just one application to, advocating inside of your enterprise for serverless, you working with people like Corey and like Jeremy and like Van and like Nizan and like Jan, and working through their experience helping other customers grow their serverless footprint, and reading about those experiences will help you. So we put their Twitter handles in the chat. We put their websites in the chat. Again, I do suggest certainly subscribing to their emails. And thank you. Well done. The other thing to say is that we did record this session, and we will be posting it and sending you information. So everyone, thank you so much. We really appreciate it.
Thanks, Jimmy.
Thank you.
Bye, guys. Take care.